Okay, so today we're going to be looking at 3.2, which is graphs of functions. So some of our learning targets here are to graph functions, identify the domain and range of functions, and evaluate functions at an indicated value. So let's go ahead and let's look at some of these graphs here. We have to know the shape of the graph in order for us to understand how to graph these out. So these I'm provided here for you are the basic shapes of the functions that we're going to graph here. So looking at this first one, it's absolute value, and you can tell it says f of x equals the absolute value of x. And remember, f of x is the same thing as your y value, it's just telling you that it's a function. So let me graph out, there's your absolute value graph. It's V-shaped, and so you have to be able to recognize that that's the way the graph is always going to go for absolute value. And then we've got another one here. This just ends up being a horizontal line, and remember from talking before, we know that this equation is going to be y equals some kind of a value. In this case, it might be something like 5. A horizontal line, it's linear, and we always write the equation as f of x equals a number or y equals a number, like y equals 5. Our next one over here, it's just a nice diagonal line. It's also a linear function, and we write that as y equals mx plus b, or f of x equals mx plus b. Again, m being your slope and b being our y-intercept there. A quadratic function, remember this is always parabola shaped. Notice it's rounded down there. It's different from the one above it in the absolute value one. Absolute value is like a V, it comes to a point. Quadratic is rounded there at the bottom. So our function for this one here, our function notation here, is f of x equals x squared. It might be x minus 1 squared. It might be x squared plus 2, but it's got an x squared in it, so it's a quadratic function. The reciprocal function, or you can also call this the rational function here. Notice there are two parts. There's like a gap there, and then we got another part over here. I had to take my pencil off the paper to go from the left graph to the right graph there. So what happens here is there's like a horizontal asymptote in here. So the x-axis there acts as a horizontal asymptote for both of those graphs to approach. And then the y-axis there is another asymptote. There's a vertical asymptote that the graph is approaching but not crossing or touching. And how that looks is you've got f of x equals 1 over some kind of an x, where we could have like y equals 1 over x minus 1. That's a reciprocal function or a rational function. And then last here, we've got a square root function. So notice we've got y equals there, the square root of x. So what happens here is there's a point here, and it's going on forever in that direction. It's almost like kind of a halfway sideways parabola. I'm not going to put this part down here. It's not there. But just so long you can kind of see how that would have been a sideways parabola. But that's the square root function. It starts at a point and then goes forever in one direction like that. And it's a curve. It's not a line. So those are our functions. Remember, functions pass the vertical line test. If you take a vertical line, such as if I drew one over here on the quadratic, notice it only goes through one point at any given time. So it definitely passes the vertical line test. So what we're going to do first here is we're going to graph these out. I'm going to make a table of values, and then we're going to graph these out. So for the most part, you can pretty much always pick the x values as -2, -1, 0, 1, 2. Now there's some exceptions, and I'll just kind of tell you how those go. But pretty much for the most part there, you can use those values. So for this one here, it says f of x there equals 5. Remember, that's like a y equals 5. They're telling you that the y value over here has to be 5. So graphing this one out, I've got those nice ordered pairs. I can go over -2, go up 5. And then I've got -1, 5. And then I've got 0 and up 5. And I've got 1 and up 5. And I've got 2 and up 5. And then I can simply connect those points. And just like we said, that's just y equals a constant, or f of x equals a constant. So it has to be a horizontal line. So we did our table, that's what it says, and then we graphed it out. We're going to do the same thing over here. And knowing that this has to be some kind of a diagonal line, I can see it's in that form of y equals mx plus b. And if you prefer to put in a y in there instead of f of x, go right ahead and do that. Some of you will graph using your y equals mx plus b. It's in that form. You might just go ahead and graph that out if you wanted to. You could go down to your y-intercept, and then you can see that your slope there is 2 over 1, so you could rise 2 from that point, and then run 1 there. And then I could rise 2, run 1. I could rise 2, run 1. So that's really my graph right there. The only thing here is that, you know, your direction says to graph by using some points here. So if we wanted to do that, we could just put our numbers on here. We could have also graphed out, when I graphed it out over here, I could have also done it my way and then named those ordered pairs. So this would be 0, -1, this would be 1, 1, and then I could put them in my table if I wanted to. This is 2, no, 3, 2, 2, 2, 3. And then my next one, we've got 3, 4. So again, we could just go ahead and, you know, use your slope and use your y-intercept there and graph that out, but then you'd have to kind of work backwards, graph it out, and then put the numbers in the table. Or we can just plug them in here. So if I take -2 and plug it in for the x, it goes 2 times -2 minus 1. That gives us -5. If I go 2 times a -1 minus 1, that's a -2 minus 1, which gives me -3. If I do 2 times 0 minus 1, that gives me -1. If I do 2 times 1 minus 1, that tells me 1. And 2 times 2 minus 1 there is 3. So if we chose them over here where we wrote them out, we said 2, 3. Well, we got that ordered pair 2, 3. We also said 1, 1 was an ordered pair. Well, there's 1, 1. We also said 0, -1 is an ordered pair. Well, we found it out that way too. So it's up to you how you want to graph that out. But if I kept plotting this out, -1, -3, and then -2, -5. So most of you are really good at graphing these out. So however you choose to do that, whether you choose to graph it out using the y-intercept and the slope and then putting the points in the table, or whether you use the table and then graph it out. But you have to do both. You have to make a table and you have to graph it out. All right, I'm seeing absolute value symbols in A and B for this example too. So right away I'm thinking, what kind of function is this? Oh yeah, it's absolute value, so it has to be V-shaped. So I know that my graph here is going to look like a V. So when I'm thinking about how to graph this one out, I'm going to pick values here that are going to work for this function the best. So what I want to think about is inside the absolute value, I want to think, how do I get 0? Inside the absolute value there. And I get 0 inside there when x is 0. So that's the only way. So I'm going to put it in the middle. So I'm going to pick 0, and then I want to, if I kind of think over here on the line here, I need 2 points to the left of 0, and I need 2 points to the right of 0. Well, those points would be -1 and -2, and then to the right of 0 on the graph there would be 1 and 2. So working through that now, I've got my nice values. I'm going to plug them in there. The absolute value of -2 is 2 minus 1. 2 minus 1 gives us 1. Absolute value of -1 is 1, minus 1 is 0. Absolute value of 0, 0, minus 1 is -1. Absolute value of 1 is 1, minus 1 is 0. Absolute value of 2 is 2, minus 1 is 1. So let's graph that out. We've got -2, 1. We've got -1, 0. We've got 0, -1. We've got 1, 0. And we've got 2, 1. And then once I have those, I'm going to connect them, and it's going to look like a V. All right, same thing for the next one here. We want to do our table here, so let's do our table here. We're going to pick some, whoops, I'm not going to pick those. We're going to go ahead and figure out, how do I get 0 inside there? So how do I get 0? Inside there? Well, you get 0 there. Kind of think about when you factor. If it was one of your factors, you'd tell me that x would have to equal 3 to get 0. So I'm going to put 3 here. I'm going to pick two numbers before 3, which would be like 2 and 1. I'm going to pick two numbers after 3, would be like 4 and 5. And then I'm going to plug them into my function there. So 1 minus 3 there is -2. Absolute value of -2 is 2. Remember, whatever comes out of the absolute value, it has to be positive. We've talked about that before. And then -1 equals 1. Or you can think about absolute values distance from 0 on a number line. 2 minus 3 there is -1. Absolute value of -1 is 1. -1 is 0. Absolute value of 3 minus 3 there would be 0. -1 is -1. Absolute value of 4 minus 3 there is 1. -1 is 0. Absolute value of 5 minus 3 there is 2. -1 is 1. So let's plot that. We've got 1, 1. We've got 2, 0. We've got 3, -1. We've got 4, 0. And 5, 1. Connecting those points and making sure it looks like a V. That's important. That's absolute value. Now let's think about quadratics. Oh, these are quadratics? Well, I know what those look like. They look like parabolas, whether they're upside right or whether they're upside down. They're still going to look like parabolas. So we're going to do our graph here. And always think before you square it, how do you get 0 in there? You get 0 in there when x is 0. So I'm going to pick two values before 0. I'm going to pick two values after 0. And I'm going to plug them right in there. So -2 times -2 squared, following the order of operations. Remember, order of operations says you have to do your exponents before you multiply. So I have to take -2 to the second power there, which gives me 4, and then times it by -2 there on the outside, which ends up giving me a -8. -1, I'm going to plug that in there. So -2 times -1 squared. -1 squared is 1 times the -2 is a -2. And then we have the next one there. We're going to plug a 0 in there. So plug in 0 there. We got -2 times 0 squared. So 0 squared is 0 times the -2 is 0. Then we've got a 1 here. Got to square the 1 first. So 1 times 1 there is 1 times the -2. So we end up getting there a -2. And then I can plug in -2 times 2 squared. 2 squared is 4 times the -2 there is a -8. So let's plot this. -2, -8. And we've got -1, -2. And then we got 0, 0. And then we got 1, -2. And then 2, -8. Again, connect it like a parabola, so it's got to be rounded there toward the top. It's upside down, but it's a parabola. All right, so then our other one over here, again, it's an x squared. We got an x squared plus 3 this time. So again, think about how do you get 0 in there when x is 0. Pick two numbers before it, before 0 and then after 0. Plug them in there. -2 squared plus 3 gives us 7. -1 squared plus 3 gives us 4. -0 squared plus 3 gives us 3. Always squaring before you add. Order of operations says you have to square before you add. 1 squared plus 3. 1 squared is 1 plus 3 is 4. Putting 2 in there. 2 squared is 4 plus 3 is 7. Plotting that out, -2, 7. -1, 4. We've got 0, 3. We've got 1, 4. And we've got 2, 7. And again, connect them like a parabola. There we go. So that is quadratics.